So guys, as you can see, all four counters are working like a charm. See, this one is incrementing, the first counter is being incremented by 1, see 35, 36, 37. Second counter increments by 3, 114, 117, 120. The third counter increments by 6, see 264, 270, 276, 282, etc. And the fourth counter is incrementing by 9. So there are 4 different variables being incremented differently. To demonstrate to you that we can use the 4 different variables to run 4 counters on this LCD. And the technique we are using is very simple. This is just a code from the previous video. I increased the number of variables. I increased the 2 variables and then corresponding to chars. So once we convert it to a string, we have the required string. Then I initialized the LCD, turned off the cursor, cleared the screen, and initially made all 4 variables to go 0. I used a do while loop with 100 repetitions. So it will repeat 100 times. And once the do while loop ends, they all go to the initial state, and within the do while loop I am just converting the integers to string for all 4 counters. Then I just move the cursor to the first row and wrote the first counter, then the second counter, then move to the second row and then wrote the third counter and then the fourth counter. And then I incremented each counter, see the first counter by 1, the second counter by 3, third counter by 6, fourth counter by 9. In this way, by following this technique, we got this result that we are seeing here. Simple as that. Hello guys, welcome to learning microcontrollers. Guys, this video is the next video in the series of LM016 programming techniques using PIC microcontrollers, using micro C for PIC compiler. And guys, in this video I will show you, now I will be using 4 counters, using 4 counters on the LCD, and I will be using 4 different variables to run them. And I will show you how you can do this. And now let's get started, and the command I will be using is the LCD CMD command. First of all, let me show you how you can connect the LCD. So let me show you. So see here in the bottom you can see 4 counters. We will be having 4 counters using LCD out CP command, and first counter will be incremented by 1, the second counter will be incremented by 3, the third counter by 6, and fourth counter by 9, and we will display these 4 counters on the LCD using the PIC16F877A microcontroller. So let's get started. Let me show you the components and then how to program them. And here in the LCD out CP command, CP refers to cursor, that we will be using the cursor command. Now let's get started. So guys, this is our LCD. Now you can see that it's an LM016 16x2 LCD, and you can see that on the first row at the left will be our first counter, on the right will be our second counter, and on the second row on the left our third counter, and on the right the fourth counter. Now guys, to connect this LCD with the PIC, we will need a potentiometer, and this potentiometer has 3 pins. It is also mentioned on the body as well. And for the LCD you have 16 pins, 1 to 16 from left to right if you hold it like this. Now guys, let's connect it with the PIC. You will short the pin number 1 and 5 of the LCD like this and connect it to the pin number 1 of the potentiometer. Then you send it to the common ground of the PIC microcontroller like this. Now guys, pin number 3 of your LCD will go to the pin number 2 of the potentiometer. Then guys, pin number 2 of your LCD will go to the pin number 3 of your potentiometer. Then you send it to the common ground like this. And the pin number 1 and 5, you have shorted them and you connect it to the 1 pin of potentiometer. Then you send it to the common ground. In this way, your LCD gets the 5 volt. And your potentiometer also gets a 5 volt. Pin number 2 of the LCD is the power, and pin number 1 and 5 together is the ground pin. And we have also given the same power and ground to pin number 1 and 3 of the potentiometer as well. Pin number 2 of the potentiometer is the variable adjustable contrast pin. You will connect it to the pin number 3 of the LCD like this. Now guys, pin number 4 is the RS pin. For this you can use any available digital input output pin of the PIC. If you use other pins, then I am using, just you have to change the programming. So you can use any available digital input output pin or a GPIO pin. For pin number 4, that's the RS pin, I am going to use the pin number 15 of the PIC, that is pin number C0 or port C pin 0. For pin number 6, I am going to, that is the enable pin of the LCD, I am going to use C1. For pin number 11 of the LCD, that is data pin 4, I am going to use C2. For pin number 12, that is data pin 5, I am going to use the pin number 21 of the PIC16F877A, that is D2. And for the pin number data pin 6, that is pin number 13 of your LCD, I am going to use the pin number D3 of the PIC. And for the data pin 7, that is pin number 14 of the LCD, I am going to use the pin number C4 of the PIC microcontroller like this. In this way guys, our LCD data pins are connected. Now guys, pin number 15 is the LCD backlight. If your LCD have a backlight, only then you will connect this pin. You will connect it to the 5-volt supply of the PIC like this, and the ground will go to the common ground like this. In this way your LCD backlight will get the power. Now guys, these 4 pins, pin number 7, 8, 9 and 10, they are for the 8-bit mode, while we are going to use this LCD in the 4-bit mode. Now guys, this will be programmed in such a way that we will take 4 variables. First variable will be displayed at will display a counter at pin number at first row left side, that will be keep on incrementing by 100 times, that the maximum it will go to 100 and then repeat all over again. Then the second counter will be incremented by 3 and it will go up to 300 and then it will repeat like 100 cycles for all 4. And then the third counter on the left of the second row will increment by 6 and it will go like 100 times up to 600 and then it will come back to 0 and start all over again. Similarly, for the fourth counter, that is the second row right part, will be plus 9. It will keep on incrementing by 9 and once it reaches 900 then it will start from 0 again. Now guys, we will simply go to our previous video of this series and we will take our, you can say that the micro C for PIC and Proteus simulation file from that video, and then we will simply modify it for this video. So just go to my channel. I will share the link to this video I'm going to use here in the description. So these are the videos. Okay, let me go to the other side which you can access as well. Okay, in the videos here, this is the last video of this series, or you can simply go to the playlist. Here we have this playlist, LM016 based programming techniques. Okay, this is the video that we have here. It says that LM016 4 counters using 2 variables. So that's what we are going to use here. Now we will make it 4 counters, 4 variables. So for that, go to its description, and I will also share directly these files, the new files I will make for this video, as a Google Drive link in the description of this video as well, and also the link to this video as well will be in the description. So guys, this is the Google Drive link. It says link to micro C and PIC files and Proteus files. Just open it and download both the files. We will use these files and then we will modify them. So this is micro C for PIC files. Click here and click on download. Okay, wait for the download to start. Just wait, the download will start. Also download the Proteus file as well. Okay, the micro C PIC files have been downloaded. Just go to the folder where you just downloaded these files. Now paste it at some suitable place where they will be easy to access. I go to C, make new file, LM016 programming techniques. Extract them. Go to the micro C for PIC files. So you have these files here. Now go back to your micro C. This is the micro C I'm going to use. It's version 7.6.0, latest version. I will also share the link to the video in which I have told you how you can download and install this version for free, full version, no crack needed. Go to file, open. Here you go. Now go to the folder where you just extracted the new file. Okay, here I have LM016 programming techniques, micro C. Open this. Okay, now it's opened. Okay, here you have that programming of the previous video. Now the problem is the debugger is not working because we have just opened it. Now you copy all this and make a new file, else your debugger will not work. So to make sure that the debugger is working, just go to the new file, standard project. Now write the name LM016 programming technique, 4 variables, 4 counters, tutorial by learning microcontroller. So that's the name I wrote. Now select the path where you want to store the files, select the microcontroller you are going to use, and the crystal you have at the pin number 13 and 14 pin of your PIC16F877A, select that. I have 20 MHz crystal over there. Click on next and finish. Now save the file. Before you do anything else, press Ctrl S Okay, the file is being saved. Now you go to the file we just downloaded, copy the code, paste in this new file. Now your debugger is working. See, the debugger is giving red lines. It means the debugger is working. Now what you do is that since we are using libraries, certain libraries, you just expand them. We are using the conversion library to convert the integer to string to display it on the LCD. We cannot display integers directly, so we need the conversion library, and we have the LCD library because we have LCD interface with a PIC. Now click on build to see either the code is working. Okay, it's built successfully. Now we can modify the code. What I do is that I simply go here and add two more variables. See, the only two variables were there. I add two more variables, and also since we have two more variables, so we integer variables, now we will need to convert them to two different strings to display it on the LCD. So I also take two more strings as well. People sometimes make mistake here that they keep on overwriting the same string for every variable, and that also makes error. So you use a separate string. An array of char is a string. Remember that in micro C you don't have directly a string like in case of Arduino. So you make an array of char, like there are total 0 to 10, 11 characters in this char variable. So it will be a string. It's an array of char which is a string. Now I rename them so they don't overwrite. So this will be increment 4, and its corresponding char in which it will be stored to displaying on the LCD. I make it like 5, and then I make it 6, and then the corresponding fourth variable and its corresponding integer, string variable will be 7. Okay, that's nice. So it's increment for increment 1, increment 2 for increment 3 string, and corresponding increment 4 for increment 5 string, and increment 6 for increment 7. Now we have 4 variables. You can see that. What I do is that I go down. Here you can see that initially only one increment element is by default 0. I make all 4 variables by default 0 because they will be 0 when the code starts. So because our counter should start from 0. If you want to start from some other value, just change these. So increment 2, increment 2, 4, 6, 2, 4, 6. They are 0 like this. Now guys, we go down here. Here you can see that we are converting the char to string to display on the LCD. Just copy these commands again. There were only 2 variables in this video. So in our video there will be 4 variables. So we will need to convert 4 values to string because we are going to run 4 counters. So whatever is in the increment, the first variable will be converted into a string, will be stored in the corresponding string variable, that is increment 1. For the second variable we have increment 2, and for the counter it will be increment 3. And for the third variable it is increment. For the third variable it is increment 4, and its corresponding string variable is 5. For the fourth variable it is increment 6, and its corresponding char is 7. That's all. So these 4 will be our counter: increment 1, 3, 5 and 7. 4 counters for 4 variables. These are the 4 variables: increment 1, increment 2, increment 4 and increment 6. Now we go down. You can see that we are using the LCD out CP command. So wherever the cursor is lost, LCD out CP command starts writing from there. So we place the cursor here by using this command LCD CMD LCD first row. It will start writing from the first row, first column, increment 1, whatever is the increment counter 1. So, and this increment counter 1 is increment is equal to increment plus 1. By default they were 0. In the first one it will be 0, and then once it's written, the cursor will move to the right, from where the first increment writing, first counter writing ends. It will automatically start writing where the cursor is lost, that where it has stopped writing increment 1, it will start writing the increment 3, that is the second counter, and it will be automatically on the right side of the first row. Now for the third counter we will need to move the cursor to the second row, and the third counter here you can see that is represented by increment 5. So we rename it to increment 5 now. Okay, go down. Okay, here we have that. So on the second row, first column, it will start writing the third counter, and that will be the increment 5. Here you can see that And now for the fourth counter, that will be written from where the cursor was last, because we are not giving any position to cursor. It will be automatically start writing from where it was last, and that was once it stopped, it is completed writing the increment 5. From where it stopped writing the increment 5, from the right point it will start writing the fourth counter, and that is our increment 7. That is the char name. You can give it any name like counter 4 as well, that will be more suitable. So this is where it will start writing the fourth counter. So now by default we gave them 0 values. So in the first run only zeros will be written on the screen. Now for the second run we need to update. Now the increment 1, that is the first counter, is incremented by 1 as shown in the presentation. For the second counter it is incremented by 3. Now we also give the values to the other two counters. Okay, let's give values to the other two counters as well. So here we go. Now the third counter is basically the integer for the third counter. See, we cannot perform processing on the strings. See, we can only do processing on these integers. So once we have converted it into a string, we cannot do processing on it. That's why it's necessary to convert the integer, do the processing on the integer, then you convert it to a string, because once converted we cannot do processing. Now this is a third counter, increment 4. So go down, make it increment 4, and as shown in the presentation, increment 4, that is the third counter, will be incremented by 6. Now the fourth counter, its corresponding integer variable is increment 6. Now this will be incremented by 9 as shown in the presentation. So increment 6 will be incremented by 9. Now the loop will repeat 100 times, and then all 4 counters will become 0 again. So it will go back to the initial state. These are the initial values. So I just copy paste the initial value here. Now the all 4 variables will go 0, and then it will start all over again. So as you can see that what is happening here is that first we initialize the LCD with the wiring done in the hardware. You can remember I gave RS to C0, EN to C1, D7 to C4. If you have different wiring, then you simply change these. You just change the value here, like if you are using D4 for the D7, just make it D4. Similarly for the direction, do the same. Now we simply initialize our variables, strings, and then we initialize the LCD because it's a function we are calling from the library. Then I turned off the cursor. If you want to turn on the cursor, you can simply remove this command. I don't like the cursor, that's why I had turned it off. Then LCD CMD LCD clear. This is the command. I cleared the screen for the first run. Then I made all the variables integers to go 0 before we go into the forever loop. Then in the forever loop, what I did is that first of all, I want to display these zeros on the screen as well. So I converted whatever is in the integer to a string, because we cannot display these integers directly on the LCD. We need to convert it to a string. So I use this command, I called this function from the conversion library of the micro C, and then I converted the whatever is in the increment to increment 1, and whatever is in the increment 2 variable, integer variable, to a increment 3, that is the char string variable, increment 4 integer to increment 5, and increment 6 integer to increment 7 char string. So these 4 are our counter: increment 1, increment 3, increment 5 and 7. Then what I did is that, as I told you, I simply use the LCD cursor command. So I move the cursor where I want to write, and then I wrote the 4 counters on the screen. Now I build the code. Let's see, are there any errors? No errors. Now let's get the Proteus file. So I think we downloaded the Proteus file as well. Okay, just check the downloads. Okay, it's downloaded. Copy this file as well and place it in a suitable folder from where it will be easy to access. So I go to C where I have placed the other file. I place it with it. Okay, here you go. I extract it here. Now what I do is that I zoom out. Let me go to the Proteus. So you just open the Proteus, click on this ISIS button, schematic capture or whatever it is called in the newer versions. Click on File, open. Now go to the folder where you have just extracted that Proteus file. I have that in C, LM016 programming techniques, Proteus file. This is the file. Just open it, and here go to double click on the PIC microcontroller, and here you go to this browse button, and you go to the place where you have just created the hex file, new hex file. So here it is. I click on open, click OK. Now I run the code and see what happens. Okay, that's wonderful. See, it is working like a charm. With 4 variables, we can run 4 counters on this LCD. Now suppose your first counter can be like you are making an energy monitoring system, then the first counter is like the ampere, this is the current, this is the voltage, the second counter, third counter is the power factor, and fourth counter can be any other value like energy, power, or whatever you are also calculating. See that they are working like a charm. So this LCD is not very easy to implement. It requires some techniques to work with. Now you can see that this cursor command is a very powerful command, somewhat difficult to use, but is very powerful command. So guys, I hope you guys learned something from this video. If you have any questions, you can ask me in the comment as well. So I will be very happy to answer. And guys, if you have any general question, you can also use my post, any post that I make in the community. You can use those posts to contact me. You just leave a comment over there. I will see that in the notifications and I will respond to you. Now you can see that it will repeat 100 times because our do while loop is repeating 100 times. See, for the 100 times, this is incrementing by 1, so it will go to 100, this will go to 300, this will go to 600, this will be the 900. Let's see what happens. Does they go 0 and start all over again? See, it has nearly reached. You can see that 88, 89, 90, 94, 5, 6, 7, 8, 9 and 100. See, all 4 counters started all over again. So this is it guys. Thank you very much for your time and have a nice day.